Hello everyone, I'm Dr. Melinda Soares Furtado. I'm an astronomer and I study star-planet interactions. But one of my cosmic joys is much closer to home, eclipses. I'm here today to share this book, Lights Out. No, not now. Phew. Thank you. The book is Lights Out, Eclipses, Whys, Wonders, Wows. It's all about the sun, moon, earth, and shadows, darkness, beauty. And it's about us, how we humans react to these grand celestial alignments. Let's get started. The sleep eclipse. We all turn with the earth once a day. When we face the sun, we work, go to school, and play. When we spin away from the sun, we move into the earth's shadow, an eclipse. Then we sleep, usually. Eventually.
I told you guys to go to bed! We are in bed!
We get so busy with our days, we forget Earth is rotating at around 1,000 miles an hour, creating day and night, or light and shadow. Spinning that fast seems so unreal. Why don't we feel the Earth going round and round? Because our Earth is huge compared to us. Its great gravity keeps us from flying off. It keeps us grounded, literally. Did you know astronauts orbiting Earth have very short days and nights? It's true. They see a sunrise and sunset every 45 minutes. Why? Because they orbit the Earth crazy fast. Over 17,000 miles per hour. When astronauts orbit out of the Earth's shadow, they say,
"We're coming out of an eclipse, everyone. Look at the beautiful sunrise."
The next part of the book shows us some huge differences between the sun and moon. Like one makes light and the other reflects light. Let's explore that some more in this next part of the book. A strange coincidence of the sun and moon. The sun is a star. Like all the stars you see on a clear night sky far from city lights. Stars produce their own light by a process called nuclear fusion. The moon, on the other hand, shines by reflecting the sun's light. It's a bumpy round rock with lots of craters and no atmosphere. Up close, the huge sun has temperatures so high, atoms are ionized. It's way too hot, so electrons can't stay attached to their atomic nucleus. This fiercely hot stuff is called plasma, the fourth state of matter. Here we see hot plasma streaming along the sun's magnetic field lines. At the sun's core, trillions and trillions of tiny hydrogen atoms ferociously race around. They constantly smash into each other to create helium and energy. That is nuclear fusion. It makes the light and heat we receive every single day. Zooming up on the moon, we see craters and ancient lava flows. Long ago, the moon was volcanic, but there's no active geology now, except for some very minor moonquakes. Almost all of these craters were created billions of years ago. So the sun and moon are very different, but have you ever noticed they're the same size in our sky? It's true. That's the strange coincidence. The sun and the moon are both half a degree across in the sky. That's small. For instance, if you stack a bunch of them from the horizon to the zenith, the top of the sky, you would have to use 180 suns and 180 moons. Crazy, huh? But are the sun and the moon really the same size? I think most of you know that the sun is ginormous compared to the moon. By diameter, the sun is 400 times wider than the moon. So why do they appear the same size in the sky? You got it. Our moon is 400 times closer to us than the sun, so they appear the same size. Look up and prove it to yourself some clear day. But never stare directly at the sun, though it's generally okay to look at sunsets and sunrises. Models like these help us understand the relationship between the Earth, Moon, and Sun. Eclipses 101. Lunar eclipses happen during the full moon. The Earth is in the middle, and its long cone shadow covers the moon. The moon turns red. Solar eclipses happen during the new moon. Now the moon is in the middle. People can't see the moon, but they can see it block the sun. From space, we see the dark shadow cones of both the Earth and moon. They look sort of like really long ice cream cones. Solar eclipses, the moon's dark shadow, the umbra, barely reaches the Earth. It's only 100 miles wide, and the Earth is 8,000 miles wide. If we speed up time, now it's the moon passing through the Earth's shadow, and we see a lunar eclipse. The reason the moon appears red is because the sun's light is being refracted, or bent, by the Earth's atmosphere. All color energies bend differently, and only the red color reaches the moon. Sometimes the moon's dark shadow doesn't even reach the Earth. This is called an annular solar eclipse. Let's do a quick experiment to see how this works. Here's the sun. The moon is going to be your moon disk. Hold it out in front of your face. Your head is going to be the Earth. Got it? Great, thanks for your participation. I'm seeing lots of cool Earths and moons out there. Now place your moon disk so it barely covers the sun. That's a total solar eclipse. Now stretch your arm out, just a little, so the sun leaves a ring around your moon disk. That's an annular eclipse. Congratulations! You can rest your arms now. From space, we can see the moon again. The reason the moon's shadow does not reach the Earth sometimes is because its orbit is not a perfect circle. It's elliptical. This changes the size of the moon in our skies. When it's closer, it appears bigger. We call that a supermoon. When it's a bit further, it's smaller, a mini-moon. Anybody wonder why we don't have eclipses every month? Every month, we have a full moon and a new moon, well, except February sometimes. Anyway, let's find out. Tilted orbits. The moon's orbit around the Earth is tilted, or tipped a little bit, about 5 degrees compared to the Earth's orbit. This huge cosmic ocean will help us illustrate why we don't have eclipses all the time. The water's surface is the Earth's orbital plane. It doesn't change. The moon's orbit is tilted with respect to the Earth's orbit. So, this causes the moon to be either above or below the waterline, as it orbits the Earth once a month. When the moon crosses the water's surface at a new moon, we have a solar eclipse. When it intersects the surface at full moon, we have a lunar eclipse. These intersection points are called the nodes. Time to discover how we learned when eclipses would appear. We started a long time ago, and it took us a long time to figure out. Predicting eclipses. Ever since we started looking up at the skies, eclipses have caused powerful reactions. But not everyone saw them, and clouds can hide many eclipses. It took a while before people started writing down sky events, like moon phases, planet positions, and eclipses. About 5,000 years ago, a monumental circle of rocks, known as Stonehenge, was built in England to help forecast the seasons. People back then needed to know the starts of winter, spring, summer, and fall, just like we do today. Some said Stonehenge foretold eclipses, But this is not true. An ancient Greek astronomer named Thales was said to have predicted a total solar eclipse in 585 BCE. An eclipse so sudden and fearful, it stopped a war between the Lydians and the Medes. While this prediction may be a legend, the Greeks were the first to rely on observations and measurements to explain natural events, instead of relying on myths. Eclipses are complex, but there are patterns. Over 2,000 years ago, in ancient Babylon, observations were written down in stone. Eclipses were critical. They were said to determine the fate of kings. The Babylonians did figure out when future eclipses would occur, but not precisely where. Edmund Halley, famous for predicting a certain comet's return every 76 years, rediscovered the Babylonian eclipse cycle and called it the Saros cycle. He improved the predictions immensely. In fact, Halley predicted the 1715 eclipse path over England to within 4 minutes. Amazing. Today, astronomers know to the exact second and inch when eclipses start and end, and where exactly they can be seen. Remember, for a partial solar eclipse, watchers still need eye protection. Here are a few eclipses coming to a sky near you. Clear skies, everyone. Before we knew when eclipses were coming, they were absolutely terrifying to people. Imagine the sun disappearing in the middle of the day. Scary shadows. The word eclipse comes from ancient Greece. It means fail to appear or abandonment. Long ago, eclipses were scary for people all over the earth. Many sought to reverse the unexpected, diminishing light. Ancient Chinese people envisioned a celestial dragon devouring the sun. To chase away the sky serpent, they banged on rocks, pots, anything they could find to chase the beast away. The Ojibwe of North America shot flaming arrows into the sky to rekindle the sun. The Ojibwe seek to live in harmony with all of nature, encouraging and assisting the sun's light. In West Africa, a story was told where the sun and moon became jealous of each other. They argued endlessly. It got so contentious. The moon engulfed the sun, what we see as a solar eclipse. And sometimes the sun refused to light the moon, what we see as a lunar eclipse. In a Korean myth, the Dark World King, troubled by the sun and moon's bright light, sent fierce fire dogs to steal their light. But the sun is too hot, and the moon is too cold, and the dogs had to spit them back out into the sky. In similar tales, cultures from across the globe blamed eclipses on all sorts of other animals. A wolf, a bear, a jaguar, a snake, and even a werewolf. No matter the demon, the sun and moon always return. Many secrets are waiting to be uncovered during an eclipse, and telescopes like this one can help. Let's check out some. Science stories. As eclipse predictions improve, more people look skyward and notice new eclipse features. Photography is invented. Telescopes get bigger and better. One eclipse story took place in 1868 with the discovery of a new element on the sun, helium. Named after the Greek god of the sun, Helios. Our next science story is a bit strange. It's about a planet near the sun. They thought it was there, but was never found, even during many total solar eclipses. They called it Vulcan. No, not Vulcan from Star Trek. Why did astronomers think Vulcan was there? Because Mercury's orbit was off a tiny bit, and people thought Vulcan's gravity was tugging on it. Neptune was discovered this way, as it tugged on Uranus. A total solar eclipse in 1919 solved the Mercury mystery. It wasn't Vulcan. It was the bending of space-time by the sun. Who said gravity is the curvature of space-time? None other than Albert Einstein. His brilliance proved how the sun's gravity well keeps all the planets racing around in their orbits. Mercury is located where the well is very deep, so its light must follow this contour of space-time. Mystery solved. The 1919 eclipse also showed how one star can have two different positions. A star has its normal place in the night sky. Then, Einstein showed how during the total solar eclipse, the star's light path will follow the curvature of the sun's gravity well. Einstein's new theory of gravity made headlines all over the world. Seatbelts, everyone. For this next part, we're going to rocket into space and look at eclipses beyond Earth. Someday an astronaut on the moon might see the Earth blocking the sun. A solar eclipse for the astronaut, but a lunar eclipse for us back on Earth. And when the sun is behind the astronaut, the moon's shadow can be seen on the Earth. A lunar eclipse for someone on the moon, and a solar eclipse on Earth. Mercury and Venus have no moons, and therefore no eclipses. Mars has a couple moons, Phobos and Deimos. They're small and look more like potatoes. NASA caught Phobos crossing the sun. That's kind of cool. Jupiter, Saturn, Uranus, and Neptune have hundreds of moons. So there are many eclipses, but none cover the sun just right, like when our moon blocks the sun. Did you know the moon is receding from the Earth? Moving away at about 1.5 inches per year. In 500 million years, there will be no total solar eclipses. When Mercury or Venus cross in front of the sun, it's called a transit. They are kind of rare. They dim the sun's light a tiny bit. Recently, telescopes in space have discovered planets going around distant stars by watching them transit in front of their star, like an itty-bitty eclipse. The star's light dims by a very small amount, but we can detect that. Thousands and thousands of exoplanets have been discovered, and this number will keep growing and growing. We're getting near the end, but before we finish, let's explore eclipse excitement. The moon's shadow makes a very narrow path across the Earth, about 100 miles wide. But remember, the Earth is almost 8,000 miles wide. But a total solar eclipse happens every 18 months on average, somewhere on Earth. So many eclipse chasers travel many miles to witness this wondrous sight. If you do not travel to the path of totality, the chance of seeing a total solar eclipse is one time every 400 years. That's why most people never get to see one. All eclipses are cool, but the most amazing is a total solar eclipse. It is wild. The startling darkness, the sun gone, eclipsed by a menacing black moon that exposes the sun's glorious white corona. It is the ultimate sky sight. One writer, Annie Dillard, said a partial solar eclipse is like flying in an airplane, while witnessing totality is like jumping out of an airplane. The experiences are definitely not the same. Okay, the aurora is awesome too. It's magical, watching our air molecules dance and pulse. It's literally electric. The cause comes from the sun, a solar flare, blasting out charged particles that smash into oxygen and nitrogen atoms 50 to 60 miles above us. But back to the total solar eclipse. As the ghostly curve of the invisible moon covers more and more of the sun's face, daylight slowly darkens. The sky feels eerie, yet is still beautiful. Animals and plants respond as if nighttime is approaching. The sun grows thinner and thinner. Then, the last drops of sunlight, Bailey's beads, the diamond ring, and finally, totality. Video and pictures of totality are magnificent, but let's convey this eclipse excitement in a different way, with audio only. Just before and after totality. Lights out.
Oh my God. Can you imagine what they thought? Oh my God!
Wow, I don't know about you, but I'm excited to go see a total eclipse. Or any upcoming eclipse. Well, that's our book today. Thanks for letting me share it with you. Clear skies, everyone.